Hi students, in this session we are going to deal with problem solving things for your exam. So yesterday we have seen around 5 questions, right? So here also we are just going to deal with some questions. It's a very important questions. So just you can see in the screen that the first question, find the relative error in Z if Z is equal to a raised to 4 into b raised to 1 by 3 the whole divided by c into d raised to 3 by 2. So in your first chapter, this thing, units and measurement, this particular portion is very important. It's a combination of multiplication and this you can see the equation there, and you can see that the equation is a combination of multiplication as well as division, right? Okay, now here your task is to find out the relative error in Z. So you can expect many questions from here like that of absolute error, relative error, mean, absolute error, like that. As this is a question session, I am not getting into details about the other things. We are just directly moving on to the relative error. How to find out the relative error of Z in this particular question. So you all know that if you are having an equation like this, a raised to 4 b raised to 1 by 3 the whole divided by c d raised to 3 by 2. So you want to find out the relative error here. So you want to find out delta z by z, right? Now you're just going to find out this thing, like you know that a raised to 4, right? A raised to 4, a is some quantity, b is some quantity, c is some quantity, d is some quantity, right? So here you want to find out the power. You just write down the power 4 into delta a by a plus, now just see the b. You can see the power of b is 1 by 3, right? Just write down power 1 by 3 into delta b by b. Now the next one is divided by c into d raised to 3 by 2, right? Or cd raised to 3 by 2. So now you will get a confusion that whether as it is a division case, you want to subtract that thing. No, don't get confused. It's always plus c. What is the power of c? It is 1 itself, right? 1 into, so I'm not writing 1 into some number is that number itself, right? So delta c by c into, that is plus, what is the power of d? That is 3 by 2 delta d by d. That means throughout a sum is taken there. So what you want to do is you want to just see what is the power of the given quantity, right? A, B, C, D, like that. You want to check out the power. You just write down the power there into or multiplied by the relative error of the corresponding quantity. So here you can see delta z by z is equal to 4 into delta a by a plus 1 by 3 into delta b by b plus 1 into delta c by c plus 3 by 2 delta d by d. So this is how you are just going to find out the relative error of z. So now in this session you can also expect some questions also, direct questions. So you may be given the value of delta a and a, the value of delta b and b, value of delta c and c, delta d and d. Okay, that means for example I can say one question, that is if a is equal to 200 plus or minus 5, that means 200 plus or minus, that 200 is what? The actual value, the true value of a, that is a is equal to 200 and delta a will be what? Plus or minus 5, that is 5 will be that delta a. That means 200 can be extended up to 205 or it can be down to 195. That is a meaning of that thing. I hope you understood this thing, this question, right? Okay. Now moving on to our subpart of the first question, that is, find the number of significant figures in the following questions. So find the number of significant figures in the following questions. So what do you mean by a significant figure? This is what we need to study there. You all know that what is a significant figure, right? Yes. That means significant figures are those digits in a number that are known with certainty plus one more digit that is uncertain. Okay, whenever you are just, physics is a subject, or physics is a branch of science that deals with measurements, and also it is very important in measurement. That means accuracy, precision, these type of things are very much needed in physics, right? So this particular term, that is the number significant figures, is very important in the case of measurements. So here many rules are there to find out the significant figures. So now the first question, that is 0.042. Here one rule is there, that is all the zeros which are right to the decimal point and left to the non-zero digit. All the zeros which are right to the decimal point and left to the non-zero digits, they are insignificant. So here you can see that the 0 here, it is not significant, and here also it is non-significant. Why? Because it is right to the decimal point and left to the non-zero digit, that is 4. So you can see these two zeros are insignificant. So the remaining non-zero digits are what? The only significant digits, that is 4 and 2. That is, the number of significant figures will be 2. Okay. Now the second question, that is 42.000. Now according to the rule of significant figures, all the non-zero digits are significant. That is 42. Out of 42, 4 is significant, 2 is significant, so total 2. And all the zeros which are right to the decimal point, they are what? They are significant. If, for example, after 0, if 1 is coming there, okay, then all the 3 zeros will become insignificant. But here there is no 1, right? There is no 1, so that all the zeros are significant there. That means you want to study the rules there before going to the exam. For the exam, you need to study all the rules of how to find out the significant figures. It is clearly given in your NCERT textbook, but in this question you can see that according to the rule, 4 is a significant number, 2 is a significant number, as well as all the zeros as they are coming right to the decimal point. That means all the 3 zeros are significant. So 4, 2, 0, 0, 0. So total there will be how many significant figures? That is 5 significant figures. So this is given as the first question. It is 2. There are 2 significant figures, and the second sub question, it is 5 significant figures there. Okay. So this is about the first question there. Now moving on directly to the second question. The speed time graph for a particle moving along a fixed direction in figure below. Calculate the distance traveled by the particle between t is equal to 0 and t is equal to 10 seconds. Particle between t is equal to 0 and t is equal to 10 seconds. Okay, so you want to find out the distance covered by the body. So whenever you get such type of question, You want to the first thing that you want to keep in your mind and you want to look is that what type of graph is given there. So you clearly from the graph it is understood that it is a velocity time graph, right? It is a velocity time graph. Now in a velocity time graph, the distance covered or distance subtended by the graph will give you what? Or the area covered by the graph. Let me take with a different color. This is the area subtended by the graph, right? Area. If you're finding out the area, this area will be giving you what quantity? It is a displacement. As it is a velocity time graph, it will be a displacement. If it is speed time graph, it will be a distance. So if I want to find out the displacement or distance covered by the body, what I want to do, and a graph is given to me, what we want to do, we want to just find out the area covered by the graph, area subtended by the graph. Then you will get what? The distance covered by the body. So in this question, it is clearly given one graph, velocity time graph, and it is like this, right? Okay. And this height is what? 12. And this is 5. And this is 0. This is 10. And you want to find out the distance covered by the body in this particular velocity time or speed time graph. So here, and the time is between 0 to 10. That means from 0 to 10, the total area covered by the graph will be this much. Yes or no? Yes. So that how you can find out the total area? You can see that there is one triangle, right angle triangle here, right? And one right angle triangle here, right? That means I am just taking this triangle like this, cutting the triangle like this, right? If I fix it together, I will get the graph, right? So here it is from 0 to 5. So total here, what is the length? 5, right? And what is the height? It is 12, right? In the second figure also 5 to 10. That means also what is the value here? 5. And what is the height here? Same height, that is 12. So what is the area of the triangle? Area of the triangle. You all know that area of triangle is equal to half into base into height. Here, what is the value? Half into, what is base? Base is equal to 5 into height is equal to 12, right? And now area of the graph will be what? You have two similar triangles, right? You have two similar triangles there. This one and here one. So that is equal to 2 into this value. 1 by 2 into 5 into 12, right? 2 cancel. 5 into 12, that is equal to 60 meters. As the graph is given meter per second, so obviously you will get the distance covered will be what? 60 meters. So this is the thing. This is how you are finding out the distance from a speed time graph. Hope you understood this thing. Let us see the next question, that is state laws of static friction. And the second sub question, rolling friction is less than the sliding friction. Why? Okay. So this is a simple question. So you all know that friction is a force between two layers in contact, right? and this particular force will act opposite to the relative motion. You all know that while we are walking also there is a friction between our foot and the ground and all, right? If you are just sliding something over the table, then obviously there is a friction between both the surface, that is the thing as well as the table surface. Okay, like that, friction is of two types. And that is, first one is static friction and the next one is dynamic friction. So static friction, when we study static friction, the word static itself means that stable or at rest. Okay, so if two surfaces are at rest, then there will be a friction between the two surfaces and we call it as a static friction. Okay, now it's a static friction. Okay, yes. When we study about static friction, we need to study about certain laws also. Okay, mainly just imagine that there is a object placed at a surface. Okay, now if I am just pushing this object to this side, okay, so obviously first you just give a small push, so the object will not move, right? Again you apply some more force, again also the object will what, it will not move again, and you increase it, and there will come a point. At that particular point, the object starts to move. That means first the object will be at point A. Now the object is at point B. That means there comes a maximum force, right? At that particular point only the object tends to move. That means till that point, the frictional force will act between the surface and that particular frictional point till the body moves is known as what? Static friction. And the maximum value of this static friction is known as another term, that is limiting friction. And you all know that if the body is having a mass m, its weight will be acting down mg, and there will be a normal reaction acting upward. Okay, and by the law of this static friction, it is clearly given that the static friction is directly proportional to its normal reaction. That means maximum, again more precisely I can say, the maximum value of static friction, F max, is directly proportional to the normal reaction. This F max can otherwise known as limiting friction. As I already told you about that limiting friction. The maximum value of static friction is limiting friction, and it is directly proportional to the normal reaction. This is the first law. And one more important point is there, that is the static friction is directly proportional to the, or simply the friction is directly proportional, or it clearly depends upon the surface of contact or the area of the surface of contact. So here, as the area increases, obviously the friction will also increase. The area of contact increases, the friction will increase there. So this is the second thing, depends upon the surface of contact. So it depends upon the surface of contact. So these are the two main laws regarding the static friction. So F max directly proportional to the normal reaction, and the second one is it depends upon the surface of contact. Okay, so this is about the third question. And the fourth question is about the third question. Now the fourth question, the process of change of state from liquid to solid is called what? And the second sub question, that is define latent heat. These are the questions that is to be discussed right now. First question, you all know that you all have a refrigerator in your house, right? And sometimes during winter, now it is a summer season and it's too hot there, right? So always your mind will say that to drink cold drinks and to have a good cup of cold water, like that. So what you will do is you will just take a tray and you will fill some water and you will keep it in the refrigerator, the freezer, right? So obviously you will get what? Ice. That's actually what you are doing. You are just changing the state of water, that is liquid state, to the ice. Ice is what? The solid state. Liquid to solid. That means the process of change of state from liquid to solid is called as what? It is nothing. It is liquid to solid. It is freezing. The process is known as freezing. That is solidification. That is liquid to solid. It's freezing. And liquid to gas, it is what? Vaporization. Liquid to gas, it is vaporization. Solid to liquid, it is melting. And solid to gas directly, it is sublimation. It is sublimation. So these are the various terms. But in this question, it is the process of change of state from liquid to solid. And it is nothing but it is freezing. Okay. So this is the first sub question, right? Now the second sub question, just see, define latent heat. So the word latent means hidden. Means hidden. Okay. We'll do some experiment. We'll just discuss one experiment. You take a beaker of water. You just keep one thermometer inside it and you heat the water. You can see that slowly the thermometer reading, it increases. The mercury will rise inside that. It will rise up to 100 degrees Celsius. Where you can see 100 degrees Celsius. Further you heat the water. What will you observe? Will the mercury level will get high or it will stay there? It will not move high or it will not move up even though you are heating it up. It will stay in that particular position, that is 100 degrees Celsius. So you can see, even though you are giving a particular heat energy to the water, the thermometer level is not rising up. That means, where does this particular heat energy is going, that you are giving is going? So it is nothing but this heat energy is not going anywhere, but it is utilized for the change of its state from liquid to gas or vapor. That means after reaching the boiling point, the further heat you give is utilized for change in state. And that particular heat energy, that particular heat is known as what? Latent heat. Because that particular heat is known as latent heat. So it is an amount of heat energy required to change the state of a matter from one matter to, or change the state of any substance from one state to another state is known as what? Latent heat. Okay. Now it's your part that many latent heats are there. Latent heat of fusion, latent heat of melting, latent heat of vaporization and all. So you got the idea. That is what is latent heat. It is a hidden heat energy. That means it is a heat energy required to change the state of a matter. This is known as latent heat. Got it? Okay. So that's about the fourth question. And now comes the fifth question. That is, the RMS value of a perfect gas is dash. So this particular question, RMS value, RMS value is nothing but it's a root mean square value. This particular question's answer can be solved out from Maxwell's distribution of molecular speeds. It gives the distribution of molecular speed, the speed of a molecule in a distribution. It's a bit complicated derivations there. So you don't need to study about the derivations. Instead, you need to study about the equations here. You need to by heart those things. So whenever you see about the RMS value, you can see if you are taking a system, if you're taking a system of gas, there are enormous amount of molecules of gas there, right? They will just randomly move from one place to another, and they will collide with each other, and we can see that we will get many types of velocities. You cannot take a particular molecule and find out the velocity. So we are just taking the RMS value, the root mean square value of the total molecules. Okay, so here the RMS value of velocity, RMS velocity of a molecule is given by root 3 RT by M. Root 3 RT by M, where R is what? The universal gas constant. What is M? It is a molecular mass of the gas. And what is T? It is the absolute temperature of the gas. So absolute temperature is T, M is molecular mass of the gas, and R is the universal gas constant. So here the RMS value of the molecule is given by root 3 RT by M. So I'm not only discussing about RMS value, just by heart these two, that is average value. This is VRMS. Now V average. What is the average value? If a question is asked what is the average value, don't get hesitated, just write down it is root 8 RT by pi M. Root 8 RT by pi M. By calculating all those things, you will get a value like this, that is root 2.55 RT by M. But just keep this equation in your mind. Just by heart this equation. The value will come like this. Okay. Now, one more value is there, that is the most probable speed of the gas. Most probable speed of a gas, which is given by root 2 RT by M. 2 RT by M. So you can see RMS value, VRMS, and V most probable. I am just giving MP. So VMP, VRMS. Okay. So these are the three values that you need to keep in your mind. That is RMS value, average value, the RMS velocity, average velocity, and most probable speed of the gas there. So from the equation itself, you can also find one more thing, that is VRMS will be greater than V average will be greater than VMP. So this is the thing that you should keep in your mind. So VRMS value, V average value, and most probable speed, Now coming to the last question, or the second sub question of the fifth one. Calculate the RMS value of oxygen at a temperature of 100 degrees Celsius. So RMS value of oxygen at a 100 degrees Celsius, at a temperature of 100 degrees Celsius. A molar mass of oxygen is given 32 grams, and R is equal to 8.31 joule mole inverse Kelvin inverse. So here you already have the equations there. So VRMS, you are asked to find out VRMS, and you have the equation that is root 3 RT by M. You have the value of R, you have the value of T, and here T is what? Absolute temperature. T is given as 100 degrees Celsius. So whenever you have a degree Celsius, you want to convert it into Kelvin. How to convert degree Celsius to Kelvin? That is that degree plus 273. That is 100 degrees Celsius is equal to 100 plus 273. That is equal to 373 Kelvin. Okay. And M is equal to what? Molar mass. So molar mass is directly given, that is 32 grams. Here it is given grams. So SI unit of kilogram mass is what? It is not gram, it is kilogram. That is, you want to multiply it with, that is 32 gram is equal to 32 into 10 raised to minus 3 kilogram. Always keep the power 10 raised to power. Rather writing 0.032. Like always it is better to write in 10 raised to this much like that, so that it is easy to cut the things out. So maximum simplify the question and do it. So we'll see whether we can do the things. Just write down those questions and we'll just do the mathematical things. So here it is given VRMS. It is given VRMS is equal to root 3 RT by M, where 3 into RT, it is given to 1 into temperature 100 degrees Celsius. It is given 100 degrees Celsius, so 100 plus 273, that is 373, right? 373 divided by M, that is 32 grams. So 32 into 10 raised to minus 3. After simplifying, you will get an answer somewhat like 539.1 meter per second. So this is the answer that you are getting from this particular question. You just do it. You have the equations in your hand. You just try it once and do it. Okay. Thank you.